Hey, nice to see you again. We are working on the Algebra 2 F word is back. Yeah, it just doesn't go away. It doesn't. Just telling you. So, okay, let's jump right in here. Warm up, factor completely. All right, grabbing my handy dandy help sheet again, which is posted at the bottom of this lesson. Okay, this is always numero uno, number one. Factor out any common terms, any, okay? Whether it's a coefficient, whether it's a variable, whether it's both. So when I say that, okay, does anything divide into both 5 and 30? Hopefully your answer is a resounding yes. 5 goes into both of those, okay? So a couple of things to make note of. Biggest coefficient, you can write number in front there with it if you would like to. And then with our exponents, it's just the opposite. It's the one smallest exponent on the variable. Now again, we did this when we did factoring before, but I know you're looking, that's a different packet, different time. Oh my gosh, Mr. H, yeah, it never goes away. So once we have those out, I have one more job, at least one more job. How do I get from here to here? Now there's a couple of different ways you can tackle this. One of them is to just ask yourself, okay, well, 5 times what gets me to 5? Well, 1. I can put the 1 if I want, but I don't have to. And if I have 1x here, how do I get to 2? I need 1 more, okay? So you can kind of think of it as reversing the distributive property. The other option you would have is to say, okay, so I got 5x squared I'm trying to get to. And I've already got 5x. Well, 5 divided by 5 cancels. And with our exponent rules, we subtract the exponents. 2 minus 1 is 1, and I just get x, and that's what I would get here. It's totally up to you. I'll do it both ways one more time here. Negative 30 divided by 5 is negative 6, and I already have 1x, and I need 1x, so I do not need an x. Or I can come over and just look at it this way. The x's cancel. 30 divided by 5 is 6, then I just don't forget the negative. So how do I know if I'm done? Because I'm going to say that a lot during this lesson. How do I know if I'm done? If I don't see a squared anymore in what's left, I'm done. That's kind of the be-all, end-all with these. Okay. So we get to the second one. You're like, okay, yeah, Hardy, I see. 4 and 81. And you try some stuff. You're like, yeah, nothing's going into those. Okay. So then the next step. It's 2 terms, 1, 2. Is it a difference of squares? Well, let's see. If I need a little hint, oh no, my face is in the way. Okay, there we go. 4 and 81 are perfect squares. And I'd mentioned before, it's not a bad thing if you have either printed one off or have one in your packet there to actually write down, hey, what am I squaring to get each of those numbers? Because one of the jobs we do when we're doing these is say, hey, what do I square to get 4x squared? 2 to get 4, x to get x squared. Okay, what do I square to get 81? 9. We don't put any signs up with these when we're doing our breakdown like this. And then once I know what those 2 things are, I can bring this back down and say, okay, now this is A and B. Those aren't A and B. This is my A, or my first term. This is my B, or my second term. So all I'm going to do to get my answer says first plus second, first plus second, first minus second, first minus second. No more squareds anywhere, so I'm done. Okay? So the flow chart can be helpful. And then I get to the last one, and I'm like, oh, man. Yeah, no, nothing goes into all of those. Guessing checkers, I still got some of you out there. I've literally seen it for some of you that are in class. But if you're not a guessing checker, if you're a guessing checker, guess and check away right here. If you're not, okay, slide that 2 on down, multiply it on down. And now it's just like our diamond problems, which basically just tell us this is my multiply number, this is my add number. So I start thinking of things that multiply to 14. 1 and 14, 7 and 2. But I need them to add to 15. Well, 7 and 2 don't add to 15. 1 and 14 do. And on a slip up on my behalf, I normally talk about using our signs as clues here, but I notice, well, they're all pluses, so I really don't have to think about that this time. 1 and 14, but don't circle this. X times x is not 2x squared. 1 times 14 is not 7, because I still need to take that 2 that I multiplied before and undo it by dividing. If the number goes in cleanly, 14 divided by 2 is 7. That's great. We do that. If it doesn't go in cleanly, if I get there and I'm like, oops, let me get out of there. There we go. And I get a decimal. We don't do decimals. Okay, well, you're like, it's still a half. Then take that denominator and slide it down to the front. Now, 2 times x is 2x squared. 1 times 7 is 7. And I have a pretty good idea that I did this right. Okay, that's some of the stuff we were doing before in factoring. The only difference now, the only thing we're going to add to the process now is, hey, let's factor, but let's find solutions this time. We're going to take one more step. So here's how this works. We're still going to do our steps for factoring. So again, anything in common, that always has to be the first question. And if the answer is no, then we go, okay, well, in this case, we're going to have multiply and add because there's no number in front of x squared. That's my clue. I got more clues. My multiply number is negative. Well, the only way I can get a multiply number that's negative is by having one positive and one negative. So I know my signs are going to be one of each. I also know from my middle term that the positive number is going to be the bigger of the two, and that they're going to be 3 apart because of the different signs. Okay? Different signs apart, same sign, add. So I start thinking about this. I'm like, okay, 40. Maybe I go to my calculator right away. Maybe I go to the multiplication chart. Maybe I'm just using my head for this. I don't know. So I get my list down. I'm going, okay, 3 apart. 3 apart. Sign of bigger number. So the 8 gets the plus, the 5 gets the minus. And normally we'd be done, but here's where the one more step comes into play. I want to know what numbers I can plug in for x that would make this 0. So here's all we got to do. Last step, maybe, there we go, is take each term or each quantity that has a variable attached to it, set it equal to 0, and solve the mini equations. Because if I plug -8 in for x, I'm going to actually do that here on this first one. If I plug in -8 for x in both of those places, I get 0. Okay? 0 equals 0. That's a true statement. And it would work for 5 as well. So typically, we're going to get 2 answers for these. But we still got to do the factoring part. So for now, again, I look. Okay, nothing in common. Wait, those numbers look familiar, though. And there's only 2 terms. I wonder if they're squares. Oh, they are. What do I square to get 16? Okay, again, handy-dandy help. What do I square to get 16? 4. Don't forget the x. What do I square to get 25? 5. And again, just follow the pattern. Use the tools, people. I'm shocked even by the number of people I see in class that don't have any of the note things out when they're trying to do this stuff. I'm like, you're either really on top of it or I don't know what's going on. First plus second, first minus second. First plus second, first minus second. And now we're back in that same situation again, where we're just And again, you're not going to get whole number answers every time. So minus my 5 and divide by 4, leave things as fractions, because you'll notice that's what the keys are going to look like. This time we're adding 5 to both sides. Okay, 2 answers. And so as we do these, we're going to touch upon every type of factoring that we've seen so far. Okay, so the first one we did a diamond. Okay, so our x squared coefficient was 1. This one, we did a difference of squares. Okay, let's see what other options we got here. So I get to the next one. Now you're like, well, it's only 2 terms, but 18 is not a perfect square, neither is 2. You're right. But maybe we got a little careless. Remember the first step, and I haven't been mentioning it, and I need to. Okay, do those two have anything in common? Sort of like number 1 was up above. Yeah, they're both divisible by 2, and I can get an x out of each of them. So now, same thing as before. You can either do the division. 2 divided by 2 is 1. X squared divided by x to the first. 2 minus 1 is 1. 18 divided by 2 is 9. I already got 1x. I don't need any more x's. But here's what I want to stress on this one. Just because there's not a set of parentheses with something doesn't mean that x plus 9 is the only thing I'm going to set equal to 0. This has an x. Now, if that would have just been 2, I wouldn't do that. It has to have a variable. But if it has a variable, it gets set equal to 0. And it's possible for me to divide 0 by 2. I just get 0. You can get 0 for an answer. And then here, subtract the 9. Still getting 2 answers. Okay? So just stick with it on this. It's just kind of a plotting process of things. Okay, so now how do I want to do this? Am I going to... Yeah, let's go ahead and do 7. I was thinking about it for a minute. Okay, so first, anything in common? No. Okay. Again, guess and check, slide and divide, whatever we got to do. Okay. Signs first. Multiply, add. Positive. So does that mean both my signs here are going to be positive necessarily? No. They're going to be the same though. So what sign are they going to be? This one. The middle sign will tell me. They're both negative. So what's that also tell me? It tells me that the 2 numbers that multiply to 12 add to 8. Same sign as add. So I start thinking about numbers. And I'm looking for the pair that's 8. Since they're the same sign, it doesn't matter where I put the 2 and where I put the 6. But again, if you're doing slide and divide, you're not done. Not done. Still got to divide by the 3. And again, if it goes in nice, great. If it doesn't, and you've reduced the fraction, you've typed this in the calculator, you've hit math, enter, enter, and it's still coming back the same thing. But now I got one step left here, which we're going to make ourselves a little extra room. I just got to set those each equal to 0. I can hear it already if we were all live and together. Hardy, is there a shortcut to this? No, not doing this algebraically. No, there is not a shortcut. Some of these things we're going to get into, I'm going to have stories. You know those stories that you always hear old people saying, like, back in the day, I walked to school at 16 inches of snow with 18 pounds of books on my back. I'm going to be doing those types of stories about how these calculators have made life the easiest thing to ever come into known to man on some stuff. But we got to get your brain working here too, because that's the best tool you got. Okay. Whoa. Now what? Okay. Whenever we get a situation like this, we want all terms to go to the x squared side. That's going to be true for 8 and 9. You're like, well, wait a minute, though. There's x squareds on both sides. Okay? If there is, we want all the x terms on the bigger x squared side. So in this instance, since 2x squared is my biggest one, I'm going to do opposites of everything else that's over here. And be careful that you're lining up like terms. I don't want to line up minus 2 under minus 3x. They're not like terms. And it doesn't mean the side disappears. It just means it's equal 0. So 2 minus 1 is 1x squared minus 3x minus 10. And now it's just a diamond problem. Life is much easier once I get through all the noise. So I give it one more shot. I notice my multiply number is negative, one of each sign. I notice my add number is negative, so the bigger number is going to be the negative. I don't even think we need a list for this one. Multiplies to 10 are 3 apart. 5 and 2. Negative is bigger. Set them equal to 0. X is negative 2. X is 5. Now, usually this is the point that somebody will ask as well, Mr. Hardy, sometimes is there going to be an answer I get that doesn't work? Is there going to be like a no solution on this? No. Nope, not currently with where we're at. That's a good question. So finally on number 9, there's my x squared side. So anything that's not on the x squared side needs to come over. Again, I don't have anything technically to add this 12x to, because this is x squared and that's just a constant. So we just got to kind of tuck that in the middle here. Now here, it depends. You may, if you're really paying attention, may notice a way to shortcut this. If you don't worry about it. I'm going to mention it at the end, though. I'm not going to do it now. But if you think you know the shortcut, go for it right now. The rest of us, we're going to pound this out, and then we're going to go, oh, yeah, when we get done. Okay, here we go. All pluses. Multiply to 36, add to 12. 6, let's see here. Again, the calculator can do what I'm doing. I've been doing this for almost 25 years now, so I'm like a human calculator. It's fun. So the only one that adds up to 12 are these two. Okay, here comes the danger. This is why this one was saved. You're like, well, 6 doesn't go into 4. I'm just going to move the 4 to the front. Don't do it. What do you mean don't do it? You've told us to do that. Yes, but math, enter. Oh, the fraction reduces. 3 halves. You have to do that part before you swing your number back over, or you're not going to get the right answer. You'd get 4x plus 6, 4x plus 6. That doesn't work. We need 2x plus 3, 2x plus 3. And for my shortcutters out there who are now giving themselves a pat on the back, okay, what do you mean there was a shortcut? If your first and last terms are both perfect squares, which they are here, 4 is a perfect square and so is 9, what do you square to get 4x squared? 2x. What do you square to get 9? 3. What are all the signs? Plus. Okay. It's a perfect square trinomial, and we talked about that before. But you notice I can still get to the answer even if I don't think about that. So don't get mad at yourself. It just, it took a little more time. And since it's the same quantity, the same set of parentheses, you do not have to solve this twice. This is the one instance that you're only going to get one answer because it's called what's called a double root. When we get into some things with solving by graphing, we'll explain what a double root means. But that'd be it at this point. Okay. One last one. We're got to get an application in. Okay, we sort of talked about this before. Area of a rectangle is 36 square feet. Find the perimeter. add up all the sides. So we got to figure out how long the sides are first. So if the area, because area is length times width, area equals, minus Hardy, minus. Somebody's gonna have to holler at me later if I forget that in a minute. We'll see. Distribute this out, x squared minus 9x. I should be out of the woods now. And so now it's a little bit more like numbers 8 and 9 were. I've got to get everything to the x squared side. So we'll bring the 36 over. We're going to have some factoring to do, which is okay. All right, let's see what we got here. Multiply number is negative, one of each sign. Add number is negative, which means the negative number is bigger. So let's see here. Okay, 36. 1 and 36, 6 and 6, 2 and 18, 3 and 12, 4 and 9. Again, if you're not sure on multiples, just start dividing small numbers in on your calculator to start getting some things. And again, since the signs are different, they're going to be 9 apart. Nope. Oh, no. I almost circled that. I'm like, those aren't 9 apart? Yes. Sign of the bigger number. 12, 3. Not quite there. Almost. Oh, wait. Yes, we are. There's no slide and divide, Hardy. Why are you trying to make more steps? You're right. So this may be the part, though, that some of you are like, well, wait a minute, though. If we're finding the length of a rectangle, how do I know which answer to use? Well, let's think about it. When you're thinking about the length of something, could something be negative in length? Maybe in some like alternate universe, but not here. But don't circle this and call it done. I want to know the perimeter. So I'm going to draw myself another little rectangle here. So this side is x, which means this side is also x. It's not just these two sides. There's not two sides to a rectangle. There's 4. And then over here, 12 minus 9 is 3. This is 3. Now add them up. 12 plus 3 is 15. Plus 3 is 18. Plus 12 is 30. Oof, duh. Okay. But that's how we actually can apply what we're doing with this. Okay. I mean, you can do that when you're doing carpentry work and other things too. You know, if you know the length and the width of the room, you can figure out how much carpet you need. If you have how much carpet you need, you can figure out how big of a room you can do. It has some application. And so you've got some options here, okay? There's a regular practice that kind of aligns with our notes here on the back. That's the best place to start. And if you still need some more practice after that, okay, jump into the practice with solving quadratics by factoring. That's what you got answer keys for. So you can check and ask questions if you need. And then I will be seeing you here soon for your lesson on solving by square roots.